Hello, everybody. My name is Masood Olia, and I'm a professor in the School of Engineering at Stanford University, and I'm here with related to mass moment of inertia and how you can calculate mass moment of inertia of like a composite body. In this case, we have a spokes, like a bicycle spokes. Okay, so let's get started. So I'm going to remove my video here, camera, and let's work on this. So it says in this problem, if the large ring, small ring, so we have a large ring here, this is the large ring, has a weight of 100 pounds, and then the small ring inside has a weight of 15 pounds. So this is the large, the small is 15 pounds, and then each rod here, each spokes, these spokes here, which are like a rod, are 15 pounds. So I call it rod. I'm sorry, 20 pounds, right? Respectively, determine the mass moment of inertia of the wheel, kind of like a bicycle wheel, right? About an axis perpendicular to the page. So the axis that's passing through O, right, which is the axis of rotation. All right, so this is a really simple problem. You need a table to know what the mass moment of inertia of different bodies are. So for example, for a thin ring, right? So like if you have a thin ring, right, like this, mass moment of inertia with respect to this axis is mr squared, mass times radius squared. Okay, be careful with the units. These are the weights. And the mass in a slug, you have to divide by gravity, g. All right, also for rods, the mass moment of inertia for a rod with respect to the axis of rotation, like this axis, let me make it smaller here, or actually use a different color. So if this is the axis of rotation, is 112 ml squared. So this is also I with respect to the centroidal axis. Okay, but we have to be careful that is the mass moment of inertia here, 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 and they're identical, by the way, right? And you have to move them to the center, to the axis of rotation of the wheel. So there is a formula called parallel axis equation. Parallel axis based on parallel axis theorem. It says I, with respect to whatever axis you want to move it, say I sub O, is I bar, this is your I bar, plus md squared. D would be the distance between this axis, the axis through this point, and it's the same for all the other points, right? And O, the axis that you want to move. So that distance, if you look at it, you see the radius of the larger wheel is 4. The larger ring. The radius of the smaller ring inside looks like 1, right? Let's just get this out of the way. And the distance d between the center of each spoke and the center of the wheel, point O, happens to be, let's see, 1 and a half of 3, right? Because remember, the length of these guys are 3 feet, right? Half of 3, that's 2.5 feet, okay? So we are ready to go. Let me actually remove some of these things and then we can redraw them. So it's really simple using superposition. So you see, let's take care of the large ring and the small ring. So based on this formula here, right? For the large ring, what do we have? Mass, be careful. The mass is 100 over 32.2. That's the mass. R squared. R is what? 4 feet, right? So remember the unit of this guy now, this becomes a slug basically, and that's feet. Feet squared. All right. What about the small ring? The small ring is 15 pounds, the weight, divided by 32.2 to change it to a slug, but its radius is 1. Now, we have 8 spokes, guys, identical, but we have to use this formula because remember, the mass moment of inertia with respect to this, the axis through the center of each rod, each spoke is what? 112 ml squared. So let's see, 112 ml squared, that's this guy, right? M is what? It's 20 pound over 32.2. Length is what? 3 feet squared plus M, again, the same mass. And remember, we have 8 of them, right? Over 32.2 again. So this is what you have to be careful with the units. And remember that distance we established is 2.5 feet. And you multiply that by 8. So large ring, small ring, and 8 spokes adds up to, let's see, 84.94 slug feet squared. Okay, that's the mass moment of inertia. Or you can actually, slug is what? Slug is pound over gravity, right? So it's actually pound foot second squared. If you change that to pound foot second squared and then multiply it by feet squared. Another way to put the unit of mass moment of inertia is pound foot second squared, which is exactly the same as a slug. Hey guys, as you, always, thank you for watching and listening. And as I said at the beginning of the video, I appreciate if you like the video. Of course, you have to like it first. And if you subscribe to my channel. Okay, thank you very much, and I'll see you soon.